Okay, sounds good. All right. Good morning, everyone. Hi. Thanks for joining our session on the deploying Couchbase Server on Microsoft Azure Cloud. I'm Anil Kumar. I'm a product manager at Couchbase. All right. I'm a product manager at Couchbase. I work on Couchbase Server, our flagship product. Along with me, I have today is Rafael from Microsoft.
Hello, guys. I'm a software engineer at Microsoft. I work on a partner team supporting ISV companies, mainly database-related companies, to best use Azure and also support Azure.
Cool. Thank you. So in this session, we will we'll talk about deploying Couchbase Server on Azure Cloud. We'll start with a quick intro to the Azure Marketplace. Rafael is going to talk about what's new in the Azure Marketplace. Then we'll go through the process of step-by-step provisioning process. We'll do a live demo of deploying Couchbase VM on the Azure Cloud. We'll talk about best practices. That's the main part of the presentation is the best practices. We'll try to keep the session very interactive. So we'll try to cover a lot of ground by talking about the best practices from the Azure side. I think Rafael will talk about it, and then I'll talk about the best practices from the Couchbase side. Right. So with that, so we'll do a basically finally we'll have a new piece thing which we want to show. It's a sneak peek of our new automated deployment process using the ARM, which is the Azure Resource Manager template. So that we will do a live demo at the end, right? We can keep the session very interactive. If you have any questions, just jump in, ask the questions. You don't have to wait to the end. With that, I will give the floor to Rafael to talk about Azure Marketplace in the beginning.
Okay, I think we're having a small issue here on the projection. Do you think it can be maybe here? Okay, great. Okay, we're back. Maybe not. Okay. Just 1 second. Okay, now you can see the screen. So we're going to divide the agenda here in some parts. So initially, I'm going to do an introduction about Azure. Then, since Couchbase running on Azure makes sense to go a little deeper on virtual machines, then I'm going to talk a little bit about VMs running on Azure, the storage part of the VMs, network, and etc. Then we're going to discuss about some best practices, how to run Couchbase on Azure, some configuration you need to think about the storage perspective, about the network perspective, connectivity, if you have multiple clusters running, if you want to connect to the on-premises environment, for example. And finally, we're going to talk about the Azure Resource Manager with the new management API for Azure, and that you can easily deploy a cluster. So, first part, introduction to Azure. I don't know if you guys are familiar to Azure, but Azure, long story short, Azure is the Microsoft Cloud platform. When you think about Microsoft and the cloud, people may not relate things very much, but if you think, Microsoft has a lot of experience on the cloud. We have many services running on the cloud. We have services for both consumers and enterprise. For example, we have Bing, Xbox Live, Hotmail, Office 365, and many other services. I believe the largest software as a services in the world is from Microsoft, which is Windows Update. If you think, we need to support billions of devices connecting to the backend, downloading updates for multiple versions of Windows. So we have a large experience running cloud environments for many, many years. And if you compare Microsoft, the Microsoft offers with the other cloud providers, we have offers ranging from running your Do you want to use DVI? Okay. Okay, so if you compare Microsoft Cloud offers with other cloud providers, you're going to see that we have many different offers, and we have offers ranging from running your development infrastructure on the cloud, and also to be able to run the cloud on a private environment. So you can run like a Hyper-V System Center, and you can create your private cloud. Actually, we have one new feature on the new release of Windows Server called Azure Stack. Right now it's on technical preview, but the idea of Azure Stack is that you can run a version of Azure on your infrastructure using the same APIs, the same management tools, and etc. So if you develop an application, you will be able to deploy this application both on the Azure public cloud or on an Azure Stack cloud that you can run on premises, for example. And between those two worlds, you also have many offers on the Azure cloud that you can use to develop your application, Office 365, for example, to run your infrastructure on the cloud, and many other options. Microsoft is the only cloud provider, according to Gartner, as the leader on the Magical Quadrants for all those offers, for example. And if you think on just Azure, we have Azure on 34 regions right now across the globe, so you can deploy your applications across those 34 regions. This is more regions than the other cloud providers combined, and we have both platform as a services and infrastructure as a services offer that you can use to run your application. We understand Azure as a hyperscalable, enterprise-grade, and hybrid environment. Hyperscalable because we have many regions and you can use many, many resources across those regions. Enterprise-grade because we understand our customers can bet on the cloud. Microsoft is betting on the Azure cloud. We run a lot of Microsoft properties on the Azure cloud already. Even internal properties like HR system, internal training websites, and etc. We migrated everything from the on-premises environments to the Azure cloud, and we are using that. We have offers running also on top of Azure. For example, Skype, Bing, Office 365, all those offers, they have parts running on Azure. And a very interesting example, just to give you an example of the scale of the environment, is a game. Microsoft released some years ago a game called Titanfall. This game, the backend for this game is running on Azure, and when we have many players playing the game, we use more than 100,000 VMs to support the game backend across all those Azure regions. So just to give you an idea about the size of the environment that you can create, I hope you can create 100,000 server VMs of a Couchbase cluster. It would be interesting. I don't think you were able to test that. It would be nice. But just to give an idea about the size of environment that you can create on this kind of infrastructure. And just to show you a little about the services we have available on Azure today. We have services on the infrastructure layer, on the computing layer that you can use to host your application. We have services to do analysis, for example. And today, we're going to talk a little about those services that are highlighted, about the Azure Marketplace, about VMs, disks, and also virtual network. Marketplace is where you can use to deploy a Couchbase environment. We have VMs available on the marketplace. It's super easy to deploy a Couchbase VM or even a cluster. We are running virtual machines to host that. The virtual machines, we keep the VM disks on the storage, so I'm going to talk a little about the storage configuration that you can do on the environment, and also through those VMs to communicate with each other. We are going to use a virtual network. And also you're going to have the ability, once you have a virtual network, to connect to the on-premises environment. So you can have a Couchbase cluster running on Azure, connecting to another cluster running on your enterprise environment, or you can have another cluster running on another Azure geography, so you can replicate the information between the clusters, for example. About VMs, when you think about VMs running on Azure, people usually say, okay, I'm going to run VMs on a Microsoft Cloud, so I need to run Windows. Yeah, that's a possibility. You can run Windows, but we also support other OSs on the Azure environment. So of course, you can run Windows, but also you can run Linux. And for Linux, we have many different options. We have Ubuntu, SUSE, CentOS, Red Hat, Oracle Linux, some versions with Docker already embedded that you can run to spin your containers, for example. For the Couchbase VM, we are running Couchbase on top of Ubuntu. And in order to create a virtual machine, you need 3 big steps. The first step is to select the tool that you're going to use to deploy the virtual machine. In the end, you will call a REST API. So if you want, you can develop an application calling directly the REST APIs, or you can use the tool that will call the API for you. So you can use the Azure portal to do that. You can use command line tools. We have the Azure CLI that is able to run both on Windows, Mac, and Linux. We have PowerShell commandlet that initially was running just on Windows, but now Microsoft has open sourced the PowerShell code. So, and there is a compilation for Linux, so you are also able to run PowerShell on Linux if you want. And those options, either the management portal or the command line tools, will call the REST API and will deploy the VM for you once you execute the right commands. When you deploy the VM, you need to define the OS. So either a Windows-based OS or a Linux-based OS. For Couchbase, we have one specific VM image with Couchbase embedded on an Ubuntu OS. And the VM size. For the VM size, we have multiple options. We have general purpose VM sizes. We have VMs optimized for CPU, optimized for memory, optimized for disk access, for example. So depending on your scenario, on your deployment, you may pick one or other VM size. Later, when we're discussing best practices, we're going a little deeper on the VM size options that you may want to deploy Couchbase. And also depending on the scenario, when you should pick one or the other size. And once you define the VM size, we're going to create the the disks, save the disks on the Azure storage, and boot the VM from there. Just a comment here, the disks, they are actually VHD files, so it's the same format that you use to run a Hyper-V on premises. So if eventually you have a Hyper-V virtual machine on premises and you want to run on Azure, it's a matter of installing some agents on the VM because using those agents, the Azure infrastructure will be able to better communicate with that virtual machine, and uploading the file to an Azure storage account that you can run the VM on Azure. So it's also easy to port a VM from the on-premises infrastructure to Azure. You don't need to convert the file to some specific format, for example. And once you create the virtual machine, the other thing you may want to do, since we're talking about a database, is to take a look on the disks. On Azure, I'm showing you a screenshot of a Windows virtual machine, but the concepts are the same for Linux. So on Azure, the VMs will have at least 2 types of disks and can have 3 types of disks. The first disk is the OS disk. So that's where we save the OS information, we boot the VM from there, and this disk is persistent. So we're saving the disk on the Azure storage. The second disk type is a temp disk. This disk is ephemeral. So if, for example, your VM crashes or the physical environment crashes, the rack crashes, for example, and you lose that virtual machine, you're going to lose the content of this temp drive. So just be aware that this disk may be fast. For example, we have VM options with SSD-based temp drive, for example. But if you lose that VM, you're going to lose the content of that drive. But depending on the scenario you're running your VM, and you may be running Couchbase, you may end up using this disk, for example. And the third disk type is data disks. So with data disks, you can deploy disks to your virtual machine. We're going to save these disks on the storage. So those are persistent disks. So we keep the data on those disks. And you can attach multiple disks on a VM. Usually the ratio is 2 disks per core. So if your VM has 4 cores, you'll be able to attach up to 8 disks. If your VM has 32 cores, the largest VM on Azure today has 32 cores, you'll be able to attach up to 64 1 terabyte disk. And once you attach the disk, you can do whatever you can do on the OS to do disk management. For example, you can combine the disks and RAID 0, for example, create a logical volume to distribute the load across the disks. You have many options to do here. Regarding the storage account, we have 2 main types of storage accounts. We have the standard storage and we have the premium storage. The difference between them is that the standard storage, the premium storage, has performance SLA. So once you have premium storage, and depending on the size of the disk you use, you will be able to achieve one specific bandwidth of performance on the disk, and also one specific number of IOPS on the disks. The standard storage doesn't have the performance SLA. And also the storage, you don't need to worry about data replication on the VM level. So for example, you don't need to create a mirror, a RAID 1 to replicate data from one disk to the other, because the storage does that for you. So every time you save a content on the Azure storage, the storage will replicate that content 3 times. And for example, if one of the copies fail, we're going to create a new copy and we'll replicate that again. And the VM will not note that. So if we have a fail in one of the copies on the storage, the VM is not going to have an error, for example, because the idea is that the storage will have an embedded high availability for your data, and you don't need to worry about that. Couchbase has the replication factor that you can replicate the data across the nodes. So if you lose a node, you're going to have the data distributed on your cluster, but you don't need to worry about replicating the data inside the VM with a mirror, for example, for the disks. And I would like to show you a quick demo how to create a virtual machine on Azure. So for that, I'm going to move to my portal. I hope we don't have issues with the projection. Okay, you can see my screen. Just let me log in. So in order to connect to the Azure infrastructure, you're going to need either a Microsoft account, which is like @live, @hotmail, and etc., or enterprise account. For example, I'm using one Microsoft account here, but I also have other Azure subscriptions using my Microsoft.com account. So once the portal loads, you're going to see that I already have actually a VM running, so I can quickly demo to you the VM information. But if I want to create something, once I have the portal running, I can click here the plus button here, and everything I want to create on the Azure infrastructure, I'm going to start with the plus here. So I have the option to create compute, network, and other services, or I can search on the marketplace. So for example, I can search for Couchbase, and I'm going to list all the Couchbase offers we have here. So I'm going to create, for example, the Enterprise Edition Gold one. And then I can fill some information, for example. On the basic information, I'm going to say which is my VM name. The VM type, if I'm going to use SSDs or regular disks, so pretty much a premium storage or standard storage. I'm going to use the standard storage just to save some funds here. Then my credential, the user I'm going to use to connect to the virtual machine. Since it's a Linux-based virtual machine, I can use either SSH key or password to authenticate on the VM. I'm going to define a password here. Then my resource group. A resource group is a logical group of resources that you're going to manage together when you deploy something on Azure. I'm creating a virtual machine, but actually we are going to create something more on the back end. We're going to create the network interface card, the virtual network for that virtual machine, the storage account to keep the disks, and etc. Network security group, so we can define which ports we can open on the infrastructure to receive connections from the internet, for example. And the resource group will group all those resources together. Then I can manage them together as well. The location, I'm going to deploy that VM. So I can deploy here on West US, which is the closest region. Once I define that, the next step I need to choose a VM size that I want to deploy that virtual machine. The recommended sizes for this specific Couchbase version that you can start are those you're seeing on the screen. But if I click View All, I'm able to select many other VM sizes available here. So there is a long list of VM sizes. So you can see pretty much the configuration of the VM sizes, so number of cores, memory, number of data disks that you can attach to that VM, so on and so forth. So I'm going to pick the A3 here. The next step, I can define some specific settings for my environment. For example, the storage account name I'm going to create, I'm going to save the disks. The network, I can either create a new virtual network, so my VMs will be able to communicate, or I can pick an existing virtual network. So let's suppose I want to deploy Couchbase on an existing environment, so I can pick an existing VM and deploy that VM on an existing VNet and deploy that VM on that VNet. So the Couchbase will be able to communicate on the network. A public IP if I want to expose that VM on the internet. Some extensions, once the VM run, I can run a script, for example. I can run a chef script, a puppet script, so on and so forth. High availability, if I want to create a cluster, I would potentially make some configuration here. I would create an availability set. An availability set is a way to tell Azure, group those VMs together, and don't deploy all the VMs on the same rack, for example, because if the rack fails, I'm going to lose all my virtual machines. So an availability set will tell to Azure that you should distribute those VMs on the physical environment, so you avoid issues if you have a physical error on the environment. Yes, please.
Do these selections affect the pricing eventually?
If those selections will affect the price? No, those selections will not affect the price. The one that may affect the price is the storage, because the storage here, since I selected regular disks, not SSD-based disks, the storage here will use the standard storage. If, for example, I'm deploying on the premium storage has a higher price. But VNet, public IP, and etc., those are embedded on the price already.
So is there any reason why you wouldn't select high availability?
I'm just going to repeat the question because we are streaming. If there is any reason to not select high availability, for example, if you're deploying a development environment, probably you don't care if the environment's high available or not. So the deployment would be simpler, would be easier to deploy without high availability, for example. So it will depend on your configuration, please.
And also, we will, as part of the best practices, we'll cover what are the, so each of these settings we see here, they have one-on-one mapping with the Couchbase server. So we'll talk about the network, we'll talk about the storage, and also the availability.
Okay. Then on the summary, we are going to review all the information we have, and we have one option here to download the template. So if I click here, for example, later I'm going to cover ARM templates, but I'm going to show you here. So I have actually a JSON file that will represent all the resources we are creating here. So it's like a graph dependency. I can say, okay, deploy a virtual machine, then deploy a storage, deploy a virtual network, and etc. But I can say the virtual machine will depend on the storage, will depend on the NIC. The NIC depends on the VNet, for example, and Azure will know the right order to create the resources. So just to show you here, this is exactly what we are deploying. So we are deploying here a virtual machine. Below here, you can see that we are pointing to the Couchbase image on the marketplace. We are deploying the storage account. If I go back here to the VM, you're going to see that VM has a dependency on the storage accounts, on the NIC, for example. And I can download those files, so I can easily replicate this environment on another Azure subscription, for example. And also I have the option to deploy this through a CLI. So if I download those files, here I have a bash script that will be able to deploy that. Or if I'm running Windows, I can use, for example, PowerShell. So I have the option to run a PowerShell script as well. I'm not going to finish the deployment here because it takes maybe 5 minutes to have the VM up and running, but I have a Couchbase virtual machine already deployed on this environment, so I'm going to show you the VM running. So I have here the VM I deployed earlier today. For example, here I have the IP address configuration for that virtual machine. If I connect here to that IP address, to the 8091, I should see the Couchbase console running. And once I have the Couchbase console, I can connect to the Couchbase cluster and pretty much do all my Couchbase management. It's loading here. And also, I have, since it's a Linux machine, I have SSH enabled on that VM. So if I want, I can SSH on the virtual machine. And since I'm running Windows 10 anniversary update, I have Bash enabled on Windows. I don't know if you guys are aware. You can do Bash on Windows now. So I can do SSH, my user, the IP, and I should be able to connect to my virtual machine. Eventually. I didn't test that. Do you think SSH is enabled on the network here?
I think it's
Okay.
no, I think it's not connected.
Okay, I need to check that later. Well, but that's the idea. Let's continue to the PowerPoint here. And now I think we're going to talk about best practices, right?
Yes.
Yay. Okay.
Sorry.
Okay.
All right, I think we can go to the next slide. Yeah.
Okay.
Right. I think so. As in the beginning, I talked about. So we'll have this part of the session. We'll make it very interactive so that we can cover a lot of ground. So we'll talk about the VM instance types, and so we'll talk about the best practices from the Azure side as well as from the Couchbase side. So as Rafael mentioned, so there are different types of instances. So you can see there is a general purpose, there's a compute optimized, memory optimized, CPU optimized, and high performance, right? So depending on your use case, depending on what performance expectations you have, we can pick different types of instances. For development purposes, if you can, obviously there's no performance expectation, you can pick a 2-core, 4 gigs of RAM, like the A3 or those kind of instance type, because you're doing just the development and testing. But if you're going to production, that's when you have to, so there is a minimum requirement for production, that is 4 cores and 8 gigs of RAM. And then there are a lot of instance types. But again, there's like, because we have different instance type, and depending on your use case, you have to test, you have to do the performance test to see which instance type is best fit for your deployment, right? So one thing which I want to talk about specifically, and again, Couchbase on the cloud, on the Azure cloud, there's a good benefit with that because it can do easy scalability, right? Because when you need more capacity, you can ad hoc add more capacity to the cluster, like, because the Couchbase itself is a shared nothing architecture. When you add more nodes to the cluster, it's basically linearly increases your throughput, right? So one of the things which I would like to highlight is like we introduced a multi-dimension scaling in 4.0 last year. With that architecture, what it gives you a benefit is basically what it gives you, like if you have a different workloads in your cluster, right? So if you have a data workload, there's a index workload and query workload. What multi-dimension scaling provides you is like isolating these workloads into a different machine, and each machine can be for different type itself. So it's basically a heterogeneous cluster, right? You have a single Couchbase cluster, and you have different machine types within the cluster, right? So for example, if I want to put the machine type for data, I want more RAM because I need more, I want to keep my active data set in memory, right? So for that, we can pick a memory optimized instance type. But if when you look at the index workload or the query workload, you need a lot of compute. In the sense, like you need a lot of horsepower to basically index your data, or you want basically handle thousands of queries coming into the system, right? So for those kind of workloads, you would go with the CPU intensive instance types, right? So depending on what workload, you can pick different instance type, and all of them can coexist in the same cluster, right? That's the beauty of like the multi-dimension scaling is you will have horizontal scaling for your data nodes, vertical scaling for your index and query nodes. Anything?
Yeah, two things I would like to highlight here is that you can see, for example, we have D/DS4, for example. The VM that has a NAS supports premium storage. So for production workload, very likely you want to target premium storage to have better disk performance. And also depending on the workload you are running, we have some VMs that will have more memory, but also they may have more local temp drive. So if you have a caching workload, for example, you don't care if you're saving the data on a stateful location, you probably may target those VMs with larger temp drives.
Agree. Yeah. Right. Right. So you want to talk about the
regarding network. So on Azure, we are able to create virtual networks. So you can deploy your virtual machines, and the virtual machines can communicate with each other. But also we can have some special configurations on the virtual networks. For example, you can create virtual networks on different geographical locations, and you can connect those virtual networks among each other. So you can create like a VPN between the Azure virtual networks. So you can have Couchbase spread across the globe on multiple locations, and they will be able to communicate through a secure tunnel. So you can have one Couchbase cluster on West US, another one on East US, and then they can communicate. Yes, please.
So if you did that type of distribution, would you treat them as if they're like they are physically at virtual different data centers and do data center replication? You wouldn't run them as a single cluster across regions, correct?
That is a very good question. So you're right. So basically, we would consider that as two different data centers, right? So we will have we use our technology called cross data center replication to replicate the data between the two data centers. So what Rafael is talking about is like when we have this so let's say you have a data center in the West Coast and a data center in the East Coast, right? So you create VNet to VNet tunneling between these two clusters, data centers, so that when you do the cross data center application, it will be much simpler to like basically the whole communication between these clusters is already set up, right? So there's a VNet which you set within the cluster. Basically, all the nodes within the cluster will talk to each other. So you set up this VNet, and there is a tunneling between the data centers itself.
Yeah. Yes, please.
If you already have the test case, do you know what kind of lag you see generally usually between the commits?
So in terms of network latency?
Yeah.
It will depend a little on the regions you are running. For example, if you have something running here in US and something in India or Japan, probably the network connectivity will be a little slower than, for example, regions inside the same country, for example. Long story short, the communication happens through the internet. So probably you're going to have some hundreds of milliseconds of latency.
Yeah.
But another possibility you have here, also you can deploy two Couchbase clusters on the same region, and you can connect those VNets through peering, or you can even deploy those clusters on the same network. And the idea is that if you enable replication across those clusters, you could use one cluster for your transactional data and another cluster to do analysis. So you can run some specific analysis tools on those on the replicated cluster, and you're not going to impact the performance of the transactional cluster. So that's also another possibility.
Good point. Just to add to that, so what we have seen is like if there is a network latency of let's say 10 millisecond, right? When we look at the cross data center replication, so the 10 millisecond is the network latency with the replication queue and how much is in the backlog, it would roughly be around 30 millisecond, right? So typically what we have, when we did this testing, if there's no replication lag, pretty much like you'll see maybe 5 or 10 millisecond latency on top of it. But if there is a replication lag, then if there is a backlog, then there is more latency on the XDCR.
Okay. Yeah, another possibility is the option to connect to the on-premises environment. So let's suppose you have a Couchbase cluster running on premises and you want to connect to a cluster running on Azure. We have two big options here. You can do a site-to-site VPN connection, which is going through a VPN gateway and through the internet, but on a SSL tunnel. And another option is to use express route. Express route is a MPLS connection between your environment and Azure. So you're going through some telecom partners from Microsoft, but using this kind of connectivity, you are able to achieve gigabits of per second. So you'll be able to get a nice bandwidth between your on-premises and the Azure environment.
Yeah.
So depending on your need, it can be a nice choice.
And so we have been seeing a lot of customers who like to do this kind of setup where they have this hybrid cloud environment where they have their on-premise deployment of Couchbase cluster, and then there is a public cloud deployment of the Couchbase cluster. So they basically have pretty much like the most sensitive data is all in their on-premise, the data center. They replicate data to the Azure, and also there is a feature in cross data center replication which is filtering. So they can filter the data which they want to replicate to the other data center. Right? With that, they basically move all the data which is they want to move to the cloud for storage purposes or for compute purposes, and they use the filtering technology for that. Cool. So we talked about the VNet which we need to create for the node-to-node communication. One of the recommended setting one of the recommendation for client-to-server communication is like if you have the apps also as part of the same VNet, then basically because Couchbase, the way the Couchbase works is like the clients will talk to every single node in the Couchbase cluster, right? They need to have access to every single node in the Couchbase cluster. So if we have a virtual network and we have the app servers as well as the Couchbase cluster in the same VNet, and in that case you basically use the private IP to communicate with all the nodes, right? So this is kind of a recommended setting, and also we have a SSL enabled for client to server communication, so you can use HTTPS to communicate to the Couchbase cluster.
Yeah, and avoid using the public IP on the internet.
Yeah.
Because you're going to do some extra network hops, so you may have some extra latency there. And also, since the clients, they need to communicate with all the nodes, it doesn't make sense to have a load balancer between the Couchbase cluster and the clients. And you have an option on the virtual network configuration, which is network security groups, that you can enable or disable some specific ports. So if you want, you can completely close the communication from the internet to your cluster. You can say all the communication from the internet I'm going to block, so no internet traffic will reach your cluster, for example. And also you can do this communication either on the subnet level or on the NIC level. So you can do a configuration on the subnet and all the VMs on that subnet will have the configuration applied, or you can do for one specific NIC, for example, and you can have a chain of network configuration. And these allow you, for example, to enable or disable communication between subnets on the same virtual network. So you can kind of create a DMZ configuration on Azure and with Couchbase if you need.
All right. So there was a question earlier about availability set, right? So as I said in the beginning earlier about, so every single setting we see on the Azure, there is a one-to-one mapping kind of thing. So we have basically what Azure provides is this availability set. And basically there are two things which I think Rafael will talk about, the upgrade domains and the fault domains. You want to talk about it, and then I'll talk about...
Yeah, basically, when you create an availability set, you are distributing your virtual machine across two big blocks we call fault domains and update domains. A fault domain is a rack. So it means Azure do not deploy all my VMs on the same rack, because if that rack crashes, I'm going to lose all my cluster. So we are going to distribute that across multiple racks. And the update domain is the configuration that once we, Microsoft, need to update the Azure environment, we can take some VM downs to apply patches, reboot the environment, and etc. if needed. It means that we are not going to take all the VMs down at the same time as well. So it's a mix of hardware failure and also environment updates.
Right. To complement that, in Couchbase, we have a feature called rack awareness. What this feature provides is like once you have configured your availability set in Azure, you can basically use our server groups in Couchbase to do the placement of the servers. So, for example, let's say if you have 6 nodes in your cluster, and you have put 3 nodes in one fault domain and the other 3 nodes in the other fault domain, in Couchbase Couchbase cluster, what you could do is create 2 server groups, group 1 and group 2, and put the 3 servers in one group and 3 servers in another group. By doing that, what it will provide is like when you when you create a replica factor of 1, so replica of the first group will be in the second group. So even if I lose the entire rack because of like the switch failure or some cases, you will still have 100% data availability, right? So that's the idea, and it can be extended like when you have like 3 clusters, three server groups, you can create 2 replicas. Then even if you lose two racks at the same time, you'll still have the 100% availability.
Would that also be the geo cluster, or it will still be in the same?
So this is within the same cluster. Yeah. So this is within the same cluster. For the disaster recovery, we use cross data center replication to replicate the data, and there are some new features coming in. So we announced 4.6 DP yesterday, but there are some new features coming for the cluster failover itself. For example, if you have cross data center replication between the 2 clusters, and because let's say if the multiple machines fail on the source cluster, the application can now basically automatically fail to the other cluster. So there are new features coming in the 4.6.
And that application, will
Yes.
that be on the database level, or that will be on the object level?
So it's very good question. The question is whether the replication is at the database level or the object level. So we create the replication on a per bucket basis, right? So like bucket in Couchbase is similar to a database, basically, right? So we create per bucket basis. You can create the replication, and you can have multiple replication for the same bucket. And also, as I said in the earlier, we have filtering capabilities. So if you want to filter the data which is going to the remote cluster, you can apply the filtering on the replication itself.
Something similar to streams.
Exactly. Yes.
I
Yes.
think
You had a
there's
question.
another question there.
Yeah, so if you lose a node that's in one of these update domains, you're going to auto fail over, and so you're going to promote all your replicas to active buckets.
Right.
And then, so all this is done without notification from Microsoft, right? They just take down a domain and say, screw it, you're on your own.
So there's capability in Couchbase, which is the auto failure of a single node, right? So basically, if one node fails in the cluster, we automatically fail over to the other to the replica partitions on the other node. So that is still there, right? So the feature which we are talking about is basically using the availability set in Azure and the complementing technology in Couchbase, which is the rack awareness, right? We don't have the automatic failure of rack yet, so that's in the roadmap. Right now, let's say if the entire rack fails, the administrator has to still go and do the manual failure of all the nodes on that rack. That feature is coming in the future, but the idea of like when multiple nodes fail in the same rack, administrator can at least quickly go, and once he gets the alert, quickly go and fail over all the nodes. You get the 100% availability on the data.
Yeah, just a quick comment. I think we are running out of time, so if we can wrap up the presentation, then we can maybe meet after the presentation if you guys have more questions.
Sure.
So the next topic, I think it's important to mention about disk configuration. Once you deploy the VM on Azure, you're going to save the content on the storage account. And in order to have a better disk performance, you can attach multiple disks to your VMs and create a RAID 0, so you can kind of load balance the requests on the disks. Also, depending on the configuration, you may or may not use the ephemeral drive because the ephemeral drive is not persistent, and avoid using the OS disk. Like if you're using a single VM to development purpose, the OS disk, I think it may be okay. But if you're running a production environment, don't save the content on the OS disk.
Right. I'll just add one couple of points. So where we can use the ephemeral drive is, so if you guys are aware of, Couchbase can act as a in-memory database as well as the persistent database also. So let's say you have a use case for caching use case where you store the session data, right? And this session data can be repopulated from the app servers. So those kind of data where you don't need persistence, basically for high performance, you can use the temporary ephemeral storage so that you get the better performance there, right? And also one thing to talk about the performance in terms of disk itself, because the VMs and the disk are the storage is on the network. Basically, it's not on the attached to the VM itself. So it's better to have those VMs and the storage in the same affinity groups so that the network latency is short.
Okay, well, we have some
Yeah,
security
so
best
from the
practices.
security perspective, I think we covered about the client to server. We have HTTPS. Similarly, for cross data center application, when you have two data centers, two cross data center applications, two data centers, and then you have replication between them, you can enable the SSL encryption for that traffic also.
Okay. And
Yes, is there a question?
I think we are
Okay.
out of time.
I think you can quickly show the UI on the, okay.
Yeah. So we are working. That's the last slide on the presentation. We are working to have on the marketplace a cluster-based deployment, so it's easy to deploy a Couchbase cluster using single clicks. This is the UI of this deployment. Right now, it's our prototype. The idea is that you will inform the cluster name, select the Couchbase version, the resource group, the location. Then you are going to pick the node configuration, pretty much, which is the VM size. You're going to give the credentials for the environment, user and password for the VM, user and password for the Couchbase administration, the virtual network, and also a number of nodes. So you want to deploy 1, 2, 3, 30 nodes, for example, and we are going to automate that deployment for you.
Yes. So it's a pretty cool thing, which is like if you want to set up a cluster of like 30 nodes, you don't have to basically set up the individual nodes and start creating multiple nodes. Using this, you basically automate the whole process of creating the 30 node cluster. Also, as I said in the beginning, so we have multi-dimension scaling, which is like if you have different services, you can basically use this template to even automate that part, right?
Okay, so if you have any questions, we can meet outside the room.
Yeah.
And also, we're going to have a Microsoft stand downstairs, I believe.
Yes, we have
and
a
I'm
booth.
going to be there, so if you want to ask questions about Azure or even check the cluster-based deployment, feel free to reach me.
Right.
Thank you, guys.
Thank you so much, guys.